All right, so for problem number 15 on our geometry review, we've been talking in class today about the things that are going to be on the test. Stuff like this is fair game. Now, decide whether there is enough information to prove that these two triangles are congruent, and they say specifically, we want to know if you can prove this using SSS. Well, then what I'm going to do is in my pencil, I'm going to say, okay, they want me to go look for SSS, and I'm going to write them over there and go, all right, well, if I can prove this SSS, then I should be able to use color coding and match up some pairs of sides. There's LM with a mark to PN. Fantastic. There's a pair of sides. That's helpful. Then I can look and say, all right, I got another pair of sides here because I can call this MP, MP. That's helpful. But then I'm dead in the water because I don't have markings on the MN and the LP. So is there enough information for SSS congruence? I get down here and I say, not a third pair of congruent sides. And so my color coding is helpful, but I stopped off because there isn't a third pair of congruent sides. Now, same thing's going on in number 16. Can we use HL? And I just want to remind you guys that if we're going to use HL, it is 3 parts. We've got to talk about a pair of hypotenuse, we've got to talk about a pair of legs congruent, and we also have to show that it's a right triangle. So just use that as a reminder, and it's back there on the board. Under the HL and the third thing, and it's in green, and I don't know why I always use green. Speaking of, I'm going to do it now. I do know that these are right triangles, so HL could work. But that's a piece, and I just highlighted that in green. That's a piece that has to be considered for HL. All of our others have 3 parts. HL does 2. The third part is tell it's right. Right angles are telling me that. When I look for congruent hypotenuse, what I notice right here, boom, that's going to be a reflexive in there. The hypotenuse is going to be congruent because of reflexive property. And then the question is, do I have then a pair of legs to go and write this proof on? And I do. I've got that, I need a different color. I've got markings on WX and ZY. And those sure are legs. So that means I got to go and prove this because it says, if you can prove it, write the proof. If not, explain why. Now, on your test, bless you. On your test, if you, right, you guys are in a position to match things like that, but you're not asked to follow through with a proof specific to these types. So there's a group of problems. I think that I said there was 4, maybe 3 or 4 of them. Decide if enough information is provided for a specific congruence. And that's kind of what we're doing here. In the specific directions to these, though, said go ahead and show a proof if they are. Now, the hypotenuse, I know in my proof I can use reflexive. And then the legs were marked, so I can use given. And the idea that it's a right triangle was marked, too, because the right angles were marked. So that just gives me my setup for a proof. So my statements, write a proof. Number 15, we didn't. We explained why we couldn't. You can have these in a bit different order if you wish, but I'm going to say, first of all, ZX is congruent to ZX. That's by reflexive. I'm going to go and talk about how I marked how the WX was congruent to YZ. That was given to us by markings. And then third step, angle W and angle Y are right angles. That was given because it was marked. Now, this is a step that some might say is required, but I haven't focused on it too much, is putting something in here that says that triangle WXYZ and triangle YZX are right triangles. And this is, I got a little star by it because I don't think we've added that all the time, but I'm going to throw it in there for you. This is just definition of a right triangle, since they have right angles. they are right triangles. We've lived without that step before. But I have my HL and I have my right. So I come down here and say WXYZ is congruent to YZX by HL congruence theorem. So matching up and color coding is going to be super helpful. Go ahead.
So for number 15, it wasn't SAS?
No, because we were missing that third pair of sides, so we couldn't write a proof.
Where MP was?
Yep. No, MN and LP. MN and LP weren't marked.
Oh, okay.
So just backing up to 15, asking a question about we didn't write a proof because we had to explain that there wasn't enough for the proof, where we were missing information. I'm going to go on to number 17. Turn the page. For problems 17 and 18, you guys didn't have a requirement of a proof. For problems 17 and 18, you did have a requirement for a proof. Make sure it's in your notes, or make sure it's in your response if we match things up. I'm not going to go so far as to do that. I'm only going to hit this like your test would. Can you use AAS? And if not, tell why. Can you use AAS? And if not, tell why. This is where all of our color coding has come into play. Do I have angle, angle, side? I'm thinking that I do. Angle, angle, side, angle, angle, side. The markings seem to make it appear that we do have angle, angle, side. I'm going to color code angle E and angle H. They've got one marking that they're congruent. There's my first pair of angles. It's given. They're marked congruent. Angle, angle, taking a look at F, what's going on at F and J. Those guys are marked congruent. There's my second pair of angles. And then I need to bring in a side congruence, and sure enough, I have it. You got it. And those things were all decide whether enough information is given to prove the triangles are congruent. And the answer to this one would be yes. And in every case, these guys were all givens because they were marked. Every single one of them was marked congruent. So that was all just givens.
On our test, can we do a proof like that, or do we have to do the
You don't have to write out a proof in problems like these. I would expect you to do something like this. That's exactly it. Use your color coding. Like I'm expecting these things to be color coded. And then again, you guys will be facing the back of the room, so you'll see all those back there. When I come over to 18, nope, not SAS. We're still 18. They're still saying, can it be AAS? And when I start looking at this one, I am going to be dead in the water, you guys, because check it out. Don't I only have a pair of angles and one pair of sides? All right, so I'm going to color code those two. I'm going to color code those two because they're given. But the thing is we've got not enough information. What would we need here? What angles would we need for AAS? Wait a minute. So I got my angles. You guys, some of you guys are giving me segments. So if it had to be an angle, angle, side, it can't be the U and R angle. It would have to be, I would have to know that V and S were congruent. Okay, so why won't this work? We would need V and S. We would need angle V and angle S marked congruent. I'd get more specific than that. That's what I'm showing you. Get more specific than that. That's what I'm showing you. Now, again, remember that in 17, in your work, you should have a proof because we said yes. 18, we explained why it wasn't working. And then the same idea is going on down here in 19 and 20. But in 19 and 20 this time, they want us to see, can we use ASA? So I write down my ASA next to it in color, and I start going, can I do this? I like the looks of this 19 because it looks like here at angle N, these guys are both congruent. And as I look ahead, too, I'm going to pull reflexive on that side. There's my side. The other angles are on the other side. This is the included side. That would be a reflexive. And then I have that last pair of angles over here at L. ASA is included side. And the reasons on this one, my side, I'm going to have to pull in a reflexive, but the angles were all marked given. You should have a proof of that one. For 19, this one should be written out in a proof on your line paper. If you have to go back and do that, you've got everything you need to make it happen. Number 20 is kind of unique because you don't see any markings of any congruence. They want ASA. It's just these parallel lines. And so when I look at parallel lines, I always go, okay, I got two parallel lines, and I think about them how two parallel lines, when they're cut by this transversal. One of the things that we kept running into in this chapter was if you've got parallel lines cut by a transversal, we were jumping in and finding some alternate interior angles congruent. And in doing that alternate interior angles thing, I'm like, all right, I'm cool. I got right here that pair of alternate interior angles are congruent. And I can say that's my A. Now my S is going to be that side that we got reflexive on. But I don't have enough for this last one because there's nothing I would need. I'm going to kind of put a star by it. I would need this angle and this angle to be congruent, and I can't assume that. And so here's my issue, is that we can't assume that, and we can't assume congruence on those. So I just put a star by it. Those are named XZY and ZXW. So those types of problems are really significant. There's a crowd of them, and it's all about color coding. I'm going to go on. Explain how to prove that K is congruent to N. This is now same idea of everything we've been doing. Taylor, go on.
Well, it was just a quick question about 20. How do you know which side, once you know the alternate interior, how do you know which side?
That's a good question. She's asking me, like, how do I know which side the angles are? Now, with the fact that we have these triangles, because she's like, why can't I say those are congruent? If you focus on the idea that transversal, like, we almost have to imagine, and I don't know if this is going to make sense to everybody, but I'm going to try to explain it and see if you can. We almost have to imagine, like, these lines just don't even matter. They don't help us or do anything with that, with those parallel lines and transversal relationship. They're not a part of it. Do you see what I mean? And so if those guys are not a part of it, then here's the thing. If I ignore them, I know this alternate exterior is congruent to this. But do you see how those alternate exteriors have been cut into?
Oh, yeah.
There you go. So that's the better explanation as to why. So, all right, now 21. Explain how to prove that angle K is congruent to angle N. This gets us into, this is our section 5-7. If I want to go and prove parts, then I should be looking, my second step should be corresponding parts of congruent figures are congruent if I can prove congruence on these two triangles. And I think I can. I look like this, I think I can. And these are where you got to figure it out yourself. These look like an SAS. And so to write a plan to prove congruence, first use SAS, and then let's give the information about that. Let's color code the SAS. HJ, ML, HJ, I don't even have to write that. I'm going to write given. They're marked. Those guys are given. They're marked. Then I grab a different color. Included angle going on here at J and M. Color code that. It's given. They're marked. Last but not least, pair of sides, marked off, given. So, explain how to prove. First use SAS, here's all of our justifications, and then in our second step, by CPCFC, the angles, those other angles will all be congruent.
Wait, so you will put angle M and angle J are congruent?
Because they're given. Nope. Angle M and J are congruent by, okay, so these three pieces justify my side angle side. As soon as I justify side angle side, what that allows me to do then is say, all right, I know these three pairs of corresponding parts are congruent. Since SAS proves the triangles are congruent, then I know these parts are also congruent, these angles are also congruent, and these angles are also congruent. it gives me permission to say the rest of the parts are. This says everything else is congruent. If it wasn't marked initially, since we can prove it, this tells us every piece is congruent. Now, in number 22, this is another one of my perfect examples of, can I try to make things look way easier than they are? Go ahead. Can we talk about it in a minute? I just want to move on with this, and I'll look at yours when we're done. If you switched up, yeah, we can talk about it in a sec. Prove that angle 1 is congruent to angle 2. That's going to be our second part of our proof. Again, you guys, if I can do, something's going to happen to get us there, but I want you guys to focus on the triangles these two triangles that are closest together. The first thing that I want you to see is that I can use SV and VT as a pair of sides because they're marked. And then I can go and say, I'm looking at the triangles. I can use this QV as QV. Reflexive, that's another pair of sides. And then I've got another pair of sides marked, that QT and QS. So I can use SSS to prove those triangles are congruent. Now, why would I want to do that? Because they want us to do angles 1 and 2. Well, as soon as I have that, so my first step is going to be SSS. And those were what? Given, reflexive, and given. Then, by corresponding parts of congruent figures are congruent, so this is second, this angle S, this angle QSV, and angle Q2TV are congruent. Now, why would I want to go do that? Angle QSV congruent to angle QTV. Well, QSV and QTV are both vertical angles with angle 1 and angle 2. And so my third step is those guys are congruent by definition of vertical angles. So I started just on these two little triangles and then said by corresponding parts, these two angles are congruent, and then I extended it and said those two are congruent by CPCFC. Last but not least, I'm stopping off on 23. That is, 23. 23, we're stopping off on 23. We're not going to do anything further. 23. Now, for this, I'm going to know who did this themselves and who didn't. I've told you guys to pick points. If you have not done this yourself, yours is going to look like mine. I'm going to pick values. My first value I'm going to pick is J is equal to, I don't know, I want J to be 6. My J is 6. So if I make my J 6, then the point R is sitting at 0, 6. Fantastic. We've done proofs like this. I want to try to get at side congruences, matching up pairs of sides. I'm going to pick an H and a K. Well, if this guy's sitting here 0, 6, I don't know, maybe H, let me put 1, K, let me put 2. That seems like it's reasonable for P here, 1, 2. That would make my Q be 1, comma, and then I got to put together my K plus J. That's going to be 8. So if you did your own with different numbers, fantastic. The idea is still going to be the same. Bless you. And this is the only, I've been asking you guys to prove these this way, give them values, and then show congruence. And as far as I'm concerned, I think we can go with this with an SSS, and I'll have to write it up in a minute. But if I can show, first of all, I can go grab those guys by reflexive. I'll have to name them in a proof. That's a pair of sides. And then what I'm going to want to do is mathematically show that the distance between R and O, I want to show that that's congruent to the distance between Q and P. And mathematically, I'm going to need to show that the distance between R and Q is the same as the distance between O and P. So I'm just going to go give these. So these are going to take calculations, and I used orange. So in my plan for these two, I got to calculate lengths and show congruence. So I'm going to use an SSS, but there's going to be some mathematics that have to back it up. So when I go to my line paper to write this proof up, I'm going to put statements and reasons. And I'm going to follow along with what Lily said. And actually, that given's going to be a minute. List your points because you gave them values. List your points because you gave them values. Leave a space for it. I'm going to throw that reflexive in first, you guys, and then I'll get at the mathematics for the other. My reflexive side was QO, QO. I'm going to throw that side in. I don't have to calculate anything. QO is QO. Why would I calculate? It's the same line. But I do have to do the calculations for those pairs that matched up. I have them in orange and green. So right now, to get at my third step, I'm hoping that I can show that RJ, and I'm sorry, not RJ, RO. So I got to come down and I got to do some math. I'm going to zoom this out. Below my proof, I want to do some math. And the math I need to do is R to O and Q to P. So you guys can see, I've got this R to O. What's that going to be? Q to P. What's that going to be? I pull in my how far aparts. R is at 0, 6. My O is at 0, 0. How far apart? 6. How far apart? 0. 6 squared. That's 30. Square root of 36. That side is 6 units long. QP. How far apart? I got 1, 8 and 1, 2. How far apart? There's my 0 and 6 again. You can stop off right here. That's the square root of 36. That's 6 if my how far aparts are the same. And then what we go to next is the same idea. So I can take this now, put it in my proof. RO is congruent to QP. My math backs up that the definition of congruence is my reason. And the definition of congruence is my reason because I just showed that they're the same measure. Fourth is going to be show the math, and I'm going to have to stop off because we're running out of time here in the second hour. Show the math to prove definition of congruence on that third pair of sides, and that's going to be our RQ. Make sure you have the math for RQ and OP. And then in the end, your triangle congruence, OPQ, QRO, is we just did a side. Oops. Just had a side there.